Imagine this. You wake up tomorrow morning, you pour yourself a cup of coffee, you look outside the window, maybe it's raining, maybe it's sunny, you remember your childhood, you remember what you had for dinner last night. Everything feels solid, continuous, real. Now imagine that somewhere in the universe, an unimaginably advanced physicist performs a single operation, not on your brain, not on your memories, but on the entire physical world surrounding you, a perfectly precise quantum operation. And suddenly, the version of you who drank that coffee, looked out the window, and remembered your childhood never leaves a trace, not because your memories faded, not because you forgot, but because the very physical process that created those memories was reversed. Did you really experience that morning, or was your conscious experience simply erased from history? Today, we are exploring one of the strangest ideas modern physics has ever produced, the Frauchiger-Renner thought experiment. Before we dive in, let's make one thing clear. This is not an experiment anyone can actually perform today. It may remain forever, beyond our technological reach. It's a thought experiment, a carefully constructed story designed to expose a crack or perhaps a hidden assumption. In our understanding of reality, physicists have argued about it for years, not because the mathematics is especially difficult, but because of what it seems to imply about observers, knowledge, and perhaps even consciousness itself. To understand why this experiment is so unsettling, we need to go back nearly a century. In the early days of quantum mechanics, physicists discovered something deeply counterintuitive. Tiny particles do not always behave as though they possess definite properties before we measure them. Instead, they are described by something called a wave function, a mathematical object that represents multiple possible outcomes. Then, when a measurement is made, we observe just one result. That raises one of the oldest questions in physics. What exactly counts as a measurement? Does the measuring device cause the change? Does a human observer? Does nature somehow choose an outcome? Or do all possible outcomes continue to exist? No one agrees. In 1961, physicist Eugene Wigner proposed a famous thought experiment. Imagine your friend performing a quantum measurement inside a sealed laboratory. Your friend opens a box and sees the result. From your friend's perspective, the experiment is over. A definite outcome has occurred. But from your perspective, standing outside the sealed room, quantum mechanics seems to suggest that the entire laboratory, including your friend, could still be described as one enormous quantum system. In other words, your friend believes the experiment has ended, but you believe it has not. Already, that feels strange. But the Frauchiger-Renner experiment asks a far more dangerous question. What happens if everyone starts reasoning about everyone else's reasoning, using quantum mechanics? Here is the cast of characters. Two scientists work inside two isolated laboratories. Let's call them Alice and Bob. Outside each laboratory stands another physicist, observing from the outside. Think of them as supervisors. So we have 4 observers in total. The details of the quantum experiment inside the laboratories are actually not the important part. What's important is this. Each observer trusts quantum mechanics. Each observer assumes everyone else is also reasoning correctly. Each observer makes perfectly logical conclusions based on what they know. Individually, every step is reasonable. Collectively, however, their conclusions become impossible to reconcile. It's almost like 4 detectives interviewing each other. Every witness tells the truth. Every deduction is valid, yet somehow the final story contradicts itself. Something has to give. Over the years, many discussions of the Frauchiger-Renner experiment have focused on this logical contradiction, and that's certainly fascinating, but I think the deepest question hides somewhere else. It hides inside one particular measurement. To understand it, we need to slow down. One of the outside observers does not simply ask, what did the scientist inside see? Instead, the observer performs an entirely different kind of quantum measurement. Imagine flipping a coin. Normally you ask heads or tails. But now imagine asking a completely different question. A question that does not distinguish heads from tails individually. Instead, it asks whether the coin is in a very particular combination of both possibilities. That sounds impossible. How can you measure a combination of two different outcomes? The answer is surprisingly ordinary, at least by the standards of quantum mechanics. Physicists do this all the time with tiny particles. Instead of measuring in one direction, they rotate the measurement into another direction. Nothing magical happens. They simply choose a different way to ask nature a question. But if you do the same thing in the Frauchiger-Renner thought experiment, something is astonishingly different. The astonishing part is not the mathematics, but the object being measured, not an electron, not a photon. As scientists usually measured in real-life experiments, in the thought experiment, the thing being measured is an entire laboratory, including another conscious human being. Now imagine what that would actually require. The laboratory cannot interact with the outside world. No stray photons, no air molecules carrying away information, no irreversible recordings. Everything inside the room, including the scientist's notebook, neurons, memories, and brain activity, must remain part of one gigantic quantum system. Then, the outside observer performs an extraordinarily precise quantum operation on the whole laboratory. Not just the scientific experiment being conducted inside the lab. Everything, including the conscious scientist inside the lab, and here is the key. Only after the outside observer performs such a gigantic quantum operation would they subsequently perform a measurement. Physicists call such an operation a unitary operation. You can think of it as an unimaginably precise rearrangement of reality, like rewinding every ripple on a pond, like perfectly reversing every domino after they have fallen, like running the universe backward, not all the way back in time, but back through one exquisitely controlled physical process. When I first learned this thought experiment, I assumed something very different. I thought the outside observer's measurement somehow erased the scientist's memory, but that's not what happens. The memory is undone before the measurement. The reversible quantum transformation itself removes the physical record. And suddenly a disturbing question appears. If memories are physical and physical processes can be reversed, what happens to conscious experience itself? Suppose you are the scientist inside the laboratory, you open the box, you see the result, you think to yourself, I definitely saw heads. That feels absolutely real. You are conscious. You have an experience. A moment later, the outside observer performs the enormous quantum reversal. Your brain returns to the physical state it had before you ever looked. Every neuron, every molecule, every memory, gone, not overwritten, not forgotten, reversed. So, did you really have that experience? Different interpretations of quantum mechanics answer this question in remarkably different ways. If you favor the traditional Copenhagen interpretation, where the collapse of wave function is outside of quantum rules, then you might say the reversal is impossible. The moment the scientist consciously observes the result, the quantum state genuinely collapses. The process is irreversible. The experiment stops there. The giant reversal can never happen. But if you believe quantum mechanics applies universally, including the measurement process itself, then the story becomes much stranger. According to the many worlds interpretation, the scientist's experience is real. Every branch of the wave function contains a conscious observer having a definite experience. Later, those branches can, at least in principle, interfere again. The observer who remembered seeing the result simply no longer exists as an independent branch. Not because anyone killed them, not because they forgot, because the branch itself ceased to exist as a separate story. Another interpretation, Bohmian mechanics, tells a different story. There is only one actual observer, only one actual experience. The scientist really does see one outcome. The experience genuinely happens, but memories are ultimately encoded in the arrangement of matter. If that arrangement is perfectly reversed, then the memory disappears. The experience occurred, it simply leaves no surviving evidence behind. Like writing your autobiography on the surface of a perfectly still lake, then watching every ripple flow backward until the water becomes smooth again. Was the story ever written? This raises a question that physics alone may not be able to answer. Is consciousness simply another physical process? Or is there something about subjective experience that cannot be rewound? Science can tell us how particles move. Science can describe neurons. Science can even describe information. But does reversing the physical state necessarily reverse awareness itself? No experiment has answered that question. Perhaps no experiment ever could. Here's something I find remarkable. When people first hear about quantum mechanics, they usually imagine Schrödinger's famous cat. A cat that is somehow alive and dead. It's bizarre, but the cat itself never tells us what it experienced. The Frauchiger-Renner experiment goes one step further. It places a conscious observer inside the box. Not just any observer, someone who is absolutely convinced they have witnessed reality, and then it asks whether that certainty can itself become part of a reversible quantum process. That's not merely a puzzle about particles. That's a puzzle about us. Perhaps the deepest lesson of this thought experiment is not that quantum mechanics is wrong. Most physicists do not think it proves that. Instead, it reminds us that every interpretation of quantum mechanics demands a price. Some sacrifice the universality of quantum theory. Some sacrifice the idea of a single objective reality. Some sacrifice the permanence of our experiences. There is no free lunch. Every worldview asks us to give up something that once felt obvious. Maybe that's what makes quantum mechanics so enduringly fascinating. Not because it tells us reality is mysterious. Every generation has believed that, but because it forces us to ask a question we rarely ask in everyday life. When you say, I experienced this, what exactly makes that statement true? The memory, the physical brain, the continuity of consciousness, or something else entirely? I'll leave you with one final thought. Imagine that somewhere beyond our reach, a civilization has mastered these extraordinary quantum operations. Suppose one of their scientists performs the perfect reversal on an entire laboratory. Every atom returns to its earlier state. Every memory disappears. Every physical trace is gone. Would anyone remain who could honestly say the forgotten experience had happened? Or would the universe itself have quietly edited its own story? Perhaps the strangest possibility is this. Maybe conscious moments do not need to last forever to be real. Maybe an experience can be completely genuine, even if afterward there is no one left who remembers it ever occurred. And if that is true, how many moments, hidden somewhere in the quantum fabric of reality, have already come and gone without leaving a single footprint? That's a thought worth sitting with. Until next time.